3 squared is 9. Since 9 is the square of 3, we say that 3 is the square root of 9. So 3 is the square root of 9. 3 cubed is 27. Since 27 is the cube of 3, we say that 3 is the cube root of 27, right? Written mathematically, that's 3 equals cube root 27. 3 to the 4th is equal to 81. Since 81 is the 4th power of 3, we say that 3 is the 4th root of 81, right? And this is how we say it. 3 to the 5th is equal to 243. Since 243 is the 5th power of 3, we say that 3 is the 5th root of 243. Right? And so how do we write that? What do I have to put where?
5.
So 5 there, 243. Expressions such as the 4th root of 81 are called radicals. A radical consists of an index. That's the number that's in the, I don't know what exactly to call that. Let's call it the crotch, I guess, of the radical sign. And the radicand is underneath the radical sign. Okay? So we write the index. The most common index used is 2, right, for square roots. And to save time, we often do not write the index of 2, or like we never write the index of 2. So if no index is written, then it is understood to be 2. So for example, the square root of 144 is equal to the square root of 144, right? The 2, but we don't write the 2. Or root 25 implies or is the square root of. Well, I see the little bar moving at the bottom, so I hope so. If not, well, it'll just be filling stuff in. Complete the following table. So the 5th root of 32, right? So we have the index is 5, the radicand, which is the thing we're finding the root, which is read as the 5th root, meaning a number raised to the exponent 5 to get 32, which is 2, right? 2 to the 5th gives us 32. So what's the index in the next one? 4. The radicand is? It's read as the 4th root of 16. A number raised to the exponent 4 to get, and the value of that is 2. Okay, next one, the index is radicand, read as the it's a number raised to the exponent 3 to get, and that number is 5. Okay, next one, the index is 2, right? An unwritten index is 2. Radicand is, it's read as the square root of 49, and it's a number raised to the exponent 2 to get 49. That number is 7. Okay, so any questions on this first bit? Square roots. If x is the square of r, then r is the square root of x. That is, if r squared equals x, then r is equal to the square root of x. Some numbers have a square root, but there are some numbers for which you cannot take the square root. What numbers do not have a square root? Negative numbers. You can take the square root of only a positive number or a 0. That is, root x exists only if x is greater than or equal to 0. Okay, so that will lead us to some non-permissible values then, right? We'll have to look. So we have non-permissible values with rationals, right, which we'll be dealing with tomorrow on the test, but we also have non-permissible values with radicals. If x squared is equal to 9, what are the two possible values of x? 3 or negative 3, right? How many square roots does a positive number have? 2, right? One positive, one negative. Positive times a positive gives you a positive, and negative times a negative gives you a positive. Positive number has a positive and negative square root, but root x, this symbol, always denotes the positive square root. Okay, so the radicand sign is the positive or principal square root. Okay, list the first 15 perfect square numbers. So 1 squared is 2 squared. Okay, so I'll just let you fill in this table, right? Okay, so we want the first 15 perfect square numbers, right? So 1 squared, 2 squared, 3 squared, all the way up to 15 squared. Okay, everybody good? List the first 10 now. On your sheet it should say 5, right? Because there's only 5 blanks there, so I think I edited that. List the first 5 perfect square powers. So what we mean by that is, well, what's x squared? Is just x squared, right? What's x squared squared? X to the 4th. What's x cubed squared? X to the 6th. X to the 4th squared? And x to the 5th squared? X to the 10th. Okay? So what we want to do is we want to be able to deal with these things because we're going to reduce radicals. So we need to know that, yeah, hey, that's a multiple of 81. 81 goes into that. I can pull an 81 out, right, to simplify things. Or, hey, there's an x to the 8th underneath the square root sign. And the square root of x to the 8th is x to the 4th, right? So the square root is just the thing that's being squared. So a power is a perfect square if its exponent is, what do these all have in common? Even. To find the square root of the, to find the square root, you divide the exponent by 2. Right, here. Whoops. That's this thing sitting up here. You have the power. Cube roots, right? Because we're not just doing squares. We've got to do cubes. We've got to do fourths. We've got to do fifths. We've got to be able to actually do any power, but if x is the cube of r, then r is the cube root of x. That is, if r cubed is equal to x, then r equals the cube root of x. State the value of each cube root. What's the cube root of 27? 3. What's the cube root of negative 64? Negative 4. Not 4. 4 cubed is 64. So you could take the cube root of any number, positive or negative. The cube root of a positive number is positive. And the cube root of a negative number is negative. Right? Since if you're cubing a negative, you get a negative times a negative, which is positive, and then you're going to multiply that by a negative, you'll get a negative. So that's going to work with any odd power. Okay? You could take the cube root of any number. Oh, we did that. List the first 10 perfect cubed numbers. So now you got to cube things, right? 1 cubed is 1. 2 cubed is 8. And so on. So even if you don't know these, you should at least be familiar with them. So if you see 343, I don't expect you to necessarily know that it's got a cube root of 7, but I expect you to know that, hey, I think that's a cube, right? I think it has a cube root. 216, I think that has a cube root, right? And then I can figure out which number is its cube root fairly easily, right? You just use your calculator. But you should recognize these as being perfect cubes. Okay, 512, that has a cube root, 729. Okay, what about cubes of powers? So again, just first 5. So x cubed, well, x cubed is just x cubed. If I square x squared, if I cube that, what do I get? X to the 6th, x cubed cubed. 9, x to the 4th cubed. And x to the 5th cubed. So power is a perfect cube if its exponent is, what can we say about these exponents? Yeah, so a multiple of 3. To find the cube root of a power, what are we going to do? Yeah, divide by 3. So divide the exponent by 3. Okay, and this will become, this is something we've got to do, and it'll become a little more obvious as we work our way through this. Higher roots. The number 16 is the 4th power of both 2 and negative 2, since 2 to the 4th is 16, and negative 2 to the 4th. Not to be confused with this. What does that evaluate to? Negative 16, right? Because it's negative 1 times 2 to the 4th. Okay, so when we're raising negatives to powers, they're in brackets, right? In other words, it's the negative 2 that you're raising to the 4th power. If you put it into your calculator like this, you'll end up with a negative. The radical 4th root of 16 represents the positive 4th root. So anytime we see that radical sign, we are only talking about the positive or principal square root, or 4th root, or 6th root, or 8th root, or any even number here, right? Any odd number here, there will be a positive root and a negative root, right? If the number is positive, the root is positive. If the number is negative, the root is negative. So when we say 4th root of 16, we're only talking about 2, not 2 and negative 2. When we say something like x to the 4th is equal to 16, then x is equal to plus or minus 2, right? So there's a difference between solving this and doing this. List the first 5 perfect 4th powers. So we got 1, 2 to the 4th, 16, 3 to the 4th, 4 to the 4th, 5 to the 4th, okay, and again, you should be familiar that these are at least 4th powers, right? That 81 is a 4th power of something. That 256 is a 4th power of something. That 625 is a 4th power, right? Okay, and then we want to do this with x's, so x to the 4th. X squared to the 4th gives me to the 8th, cubed to the 4th, 4th to the 4th, and 5th to the 4th. Since 2 to the 5th is 32, the 5th root of 32 is 2, and we write the 5th root of 32 is 2. Similarly, since negative 2 to the 5th is negative 32, we take the 5th root of negative 32 as negative 2. Like cube roots, you can take the 5th root of any number. The 5th root of a positive number is positive, and the 5th root of a negative number is negative. This will also hold for 7th roots, 9th roots, 11th roots, basically any odd power. Okay, 1 to the 5 is 1, 2 to the 5th, 32, 3 to the 5th, so you might want a calculator to help you out here. Okay, and again, you should at least be familiar with all the powers of 2, right? So you know that 2 to the 5th is 32, 2 to the 6th is 64, that if you see a number like 32, 64, 128, 256, and so on, that you realize that those are powers of 2, right? And may also be powers of 4, right? Because 1,024 is 2 to the 10th, but it's also 4 to the 5th. And let's fill this one in. X squared to the power of 5 is x to the 10th. Cubed to the power of 5. Okay, so fourth powers are, what's special about these guys? Divisible by 4. Fifth powers are divisible by 5. Okay, so this is both a fourth power and a fifth power, right? It's x to the 5th to the 4th power, and it's x to the 4th to the 5th power, right? So we can take the 4th root of this, or we can take the 5th root of this, right? 4th root of this is x to the 5th. The 5th root of this is x to the 4th. To find a particular root, we divide by the powers, right? So if it's a 5th power, we divide by 5. 4th, we divide by 4. Summary. A radical is an expression of the form the nth root of x, where n is a natural number. The symbol is called the radical sign. N is called the index, and x, is called the radicand. If the index n is blank, then the radicand, the nth root of x, exists for all values of the radicand x. If it's odd, right? Because we can take odd roots of positive numbers and odd roots of negative numbers. If the index n is even, then the radicand x must be positive. If n is even, then the expression, the nth root of x, represents only the, which root? Positive. Right, or principal root. Okay? So we know that if we square 2, we get 4. We also know if we square negative 2, we get 4. But if we write the square root of 4, we're only interested in the 2. All right, simplifying radicals. So you've done this before, right? We're going to just step it up a notch. So radical is in its simplest form if the following are true. The radicand does not contain a fraction or any factor which may be removed, and the denominator does not contain a radical. So we are not allowed to have radicals in the denominator, like this, this, or this. Okay? We are not allowed to have a factor in there which can be removed. So that 7 root 2 minus 3 is in its simplest form, right? There's nothing you can do to simplify it. Okay, expressed as a simplified mixed radical. So what we're doing is we're changing from an entire radical, root 72, we want to change that to a mixed radical. If there's a variable there, we want to state the values of the variable for which the radical is defined. Okay? So we start with root 72. How are we going to simplify that? Yeah, 36 times 2. So what we're looking to do is we're looking for factors of 72. But not any factors, right? Because factors that pop to mind are usually 8 times 9. But 8 times 9 doesn't help us, right? Because the 8 doesn't have a square root. We're looking for factors where one of the numbers is a perfect square. And not just any perfect square like 9, because it does go in, but the largest perfect square. So actually, we'll do this 2 ways. We'll do it the easy way, and then we'll do it the hard way. So the easy way is to say, okay, I'm going to write this as the root of 36 times 2. In other words, I want to factor it, and I want one of the factors to be a perfect square, but not just any one, the largest perfect square, which is the 36. I can then split this out and write it as root 36 times root 2, which is 6 root 2. Okay, that's the easy way, right? We found the largest perfect square that goes into 72, which is 36. The hard way, or not, the hard way, a hard way, is to write this as the root of 8 times 9. So 9 is a perfect square, right? That's good. So actually, let's change this. Let's write it as the root of 9 times 8, which make life a bit easier. So 9 times 8, which would be root 9, root 8, which would be 3 root 8. But at this point, you have to recognize, well, wait a sec, there's a perfect square that goes into 8, which is what? 4. So now we write this as 3 root 4 times 2, which is 3 root 4 root 2, which is 6 root 2, right? Root 4 being 2. So you can get 6 root 2 this way or this way, all right? And sometimes we don't always find the largest perfect square, you know? Sometimes it's a 64, but we only recognize that 16 goes in. So there's a little bit of a hint. If 4 goes into the number, then check if 16 goes into the number, right? Because that's just a higher square. Check if 4 and 16 go in, then check if 64 goes in, because that's a higher square yet again, right? Okay, root 150. So what's a perfect square that goes into 150? 25. So you can write this as the root of 25 times 6. Now, one of the hints that you're going in the right direction is 6 doesn't have a square root that goes into it. And one of the hints down here you're going in the wrong direction is 8 does have a square root. So if you think it's 9 times 8, but this is, wait a sec, 8 has a square root, which is 4. 9 times 4 is 36. You can get there at this stage, which will make life a lot easier, right? So just recognizing that, wait, there's still a square. Okay, in this case, there isn't. So this becomes root 25 root 6, which is 5 root 6. Now, as far as any work that you have to show, you can write root 72 equals 6 root 2. No work needs to be shown. So in simplifying radicals of this type, you really don't need to be showing anything. You don't need to split it out. If you want to, that's fine, right? If you want to take a sheet of scrap paper and do it on there, that's fine. If you want to, do it somewhere else, that's great. If you want to just be able to look at this and say, hey, that's 16 times 6. The root of 16 is 4. 5 times 4 is 20. This will be equal to 20 root 6. And, excuse me. Thank you. If that's what you want to write down, that's cool, right? Because it's also correct. If you want to break it down, that works too. So we've got the 5. What is the perfect square that goes into 96? 16, right? If we don't recognize 16, we should at least get 4 goes into it, right? And 4 goes into it 24 times, at which point you go, wait a sec, 4 goes into 24, which means if 4 goes into it once and then 4 again, then 16 goes into it. Okay? So this is the root of 16 times 6, which is 5 root 16 root 6, which is 20 root 6. What's the square root of x to the 10th? X to the 5th, right? You just take half the power. So since that's even, it has a square root, right? And the square root of x to the 10th is x to the 5th. What is the square root of y to the 25th? Doesn't have an even number that goes into it, right? So here's what we're going to do. I'm going to write it as the square root of y. Take the largest even number, which is y to the 24th, and y. So I'm going to write y to the 25th as an even power, which has a square root, and an odd power, which doesn't. And then we split this up. So it's the square root of y to the 24th times the square root of y. What's the square root of y to the 24th? Y to the 12th, right? We take half the power. So it would be y to the 12th times root y. So if we're talking square roots, we can never leave an even power underneath the radical sign. Right? We always have to take it out. And what do we take out? The largest even power. If it's cube root, it'd be the largest multiple of 3. If it's a fifth root, it'd be the largest multiple of 5, which in this case, the fifth root of that is just y to the 5th. If it's a sixth root, it'd be the largest multiple of 6, and so on. Which means that whatever's underneath the radical sign has to be smaller than whatever the index is. Right? If the index is a 3, you can't have a 3 here, because then you could just cube root it. Right? So you'd have to have a 2 or a 1 or a 0. All right, root a to the 11th, b to the 6th. So you could just write it out, right? You can go a to the fifth b cubed root a. That's what it's equal to. So it's equal to a to the fifth b cubed root a. How do we get there? Well, I'm going to do even power. So I'm going to go, it's a to the 10th, b to the 6th, and then a. The a to the 10th has a square root. So I'm now going to write this as the square root of a to the 10th times the square root of b to the 6th times the square root of a. And then the last line, the square root of a to the 10th is a to the 5th. The square root of b to the 6th is b cubed, and the square root of a is the square root of a. It's just that odd one that's left over. So you can go straight from here to here. Okay? Or you can split it out. Same thing here, right? Root 20. Well, root 20 is 4 times 5, which is 2 root 5. So it's 2 root, okay, I got a 5. B to the 9th, the largest is b to the 8th. Okay, wait a sec, I'm going to need something out here then. So 2, it'll be b to the 4th. C to the 5th, it'll be c to the 4th, there'll be a c squared. What's left? We got a 5, we got a b, we got a c. Okay, if you can do that, great. If that's right, even better. Okay, if you want to split it out, here's how we split it out. So the first thing we do is I want all my perfect squares, right? So I've got a 4, because that has a square root. I've got b to the 8th, it's even. I've got c to the 4th, it's also even. Then what's left? Well, I need a 5. The b to the 8th leaves me with one more b, right? To give me b to the 9th, and the c to the 5th leaves me with one more c. The root 4 is the 2, the root of b to the 8th. Okay, so it's root 4. Well, actually, I guess we could just at this point. So here we could probably just write the root of 4 b to the 8th c to the 4th times the root of 5bc. This has a square root, right, which is 2 b to the 4th c squared, and this doesn't have a square root. It's what's left over. It just comes down here. Okay? So whatever works for you. If you can look at that and just write the bottom line, the final answer, great. And if you need to split it out and then split it and then do this, also great, right? Nothing wrong with that. Okay, any questions? Okay, so let's go from square roots to cube roots, right? This should all be somewhat familiar, right? Maybe not working with the variables, but like the 5 root 96, that's 10c stuff, right? That's just grade 10 stuff. But now we move into cube roots, which is also this cube root 40, that's 10c stuff, right? So what's the largest cube that goes into 40? 8, right? 2 cubed, right? So it's 8. So you got to know your cubes. 1 cubed, okay, we never worry about 1, right? 1 to the anything is 1. So 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. Okay, usually they're not big numbers, so there's no point in trying to divide that by 27. So it's the cube root of 8 times 5, which is cube root 8, cube root 5, which is 2 cube root 5. Now if you want to go directly from there to there, perfectly fine, right? One big thing, make sure that if it's not a square root, if it's any other root, make sure you're writing the index in. Okay? And then you don't forget it, because it's just little half marks all over the place, right? No, that's supposed to be a cube root. You know, I circle it, you're losing a half mark. That one was supposed to be a 5th root. Okay, so just make sure you're writing the index in. Cube root of negative 500. What's the largest cube that goes into 500? 125, right? And what we're going to do is, we're going to put the negative with the 125. So it's the cube root of negative 125 times 4, right? We've just factored the 500 into a perfect cube, 125 and then the other number, which is 4. We then split it out. Cube root negative 125, cube root 4, and write that as negative 5 cube root 4. Okay, so if there's a negative under the radical, then two things. The index has to be odd, right? Otherwise, it's undefined. So if there's a negative in the radicand, if the radicand is negative, let's use the technical term, right? If the radicand is negative then the index has to be odd. And when we simplify, we will take the negative outside. Okay? We'll remove the negative. Okay, 576. What's the largest perfect cube that goes into 576? 64. Okay, how many times does 64 go into 576? 9? Okay. 9 doesn't have a cube root that goes into it, right? So if we say it's 64 times 9, we know we've got the simplest form, right? Just same as when I'm doing root 72. If I go 9 times 8, then I can say, well, wait a sec, 4 goes into 8, which means that the number should be a 36. So if we go cube root of 64 times 9, there is no cube that goes into 9. So it's negative 8 cube root 64. I'm showing more detail than really is necessary, right? I mean, at this point, you should just be able to write the answer. But, let's do this. So the cube root of 64 is? 4. Times negative 8 gives me negative 32. Okay? And if you want to go from this to this, I'm okay with that, right? I don't expect to necessarily see any work. Although in this one, maybe, because that's not really obvious. Okay, but the cube root of m to the 17th. Well, I can't do a cube root of 17, right? Because it's got to be divisible by 3. So 17, no. 16, no. 15, right? So we're going to write this as the cube root of m to the 15th times m squared, right? So all we're doing is factoring. We're looking for the largest multiple of 3. That's the factor. So in this case, 15, right? So that becomes the cube root of m to the 15th times the cube root of m squared. What's the cube root of m to the 15th? M to the 5th. Cube root m squared. Okay, so in this case we're looking for the largest multiple of 3 that will go into the power. We write it as a product of the largest multiple of 3, which is a power, right, that goes into it. Okay, next. Okay, what cube goes into 108? 27, right? So this would be 27 times 4. So I'm going to write negative 27. What's the largest power of p that I can do with p to the 7th? P to the 6th. Okay, r squared, there's no power that I can do, right? Because it's squared and it needs to be at least 3. So that's the thing that has, right? I could take this out. This has a cube root, which is negative 3p squared. What's left? Well, I've got a 4 to give me the negative 108. I've got a p to give me the p to the 7th, and I have an r squared. So this part has a cube root. This part doesn't. It will remain under the cube root sign. So we can now split this into the part that has a square root, or sorry, cube root, and the part that doesn't have a cube root. The cube root of this is negative 3 p squared, and the cube root of this is just the cube root of this. Four p r squared. How do you know if you're right? Well, basically there shouldn't be any perfect cubes as numbers, and there should be nothing with a power higher than 2. Right? If I have a 3 under there, then I could have taken it out. Okay, questions on this stuff? Okay, so that's cube roots. What's next? Fourth roots and fifth roots. What's the fourth root of 64? Okay, 64 doesn't have a fourth root, right? So what's the largest fourth root that goes into 6? What's the largest fourth power that goes into 64? 16, right? So we're going to write this as, again, if you can just write it at the bottom, right? If you can just write it as 2 fourth root 4, that's fine, right? If you need to see, wait a second, where does that come from? So we factor the 64 into a number that has a fourth root. There's no point writing it as 32 times 2, right? That won't do me any good. I need a number that has a fourth root, 16, largest number in this case. A number that doesn't, because the next higher fourth power is 81, right? 3 to the fourth is 81. There's no way that goes into 64. So it's the fourth root of 16 times the fourth root of 4, which is 2 fourth root 4. Okay, so why don't you work your way through these fourth roots, right? And I will lag a little behind you, so if you want to check your answers, I'm just going to give you a little bit of a head start. So start working. I'll just pause this for a moment. Let you start working. You should. Fourth root. It's got to be 625, right? Okay, so that one's 256 and 2. And powers, I'm looking for the largest multiple of 4, which would be 20. And here I'm looking for multiples of 4. And I'm looking for what's left over. Smaller. Okay, and so that last fourth power, we're looking for largest multiple of 4, a to the 9th. The largest multiple of 4 will be a to the 8th. B squared, there is no multiple of 4 that goes into that. And c to the 7th, c to the 4th goes into that, leaving me with an a to the 1 to give me the 9. C to the 3 to give me the cubed, and the b squared by itself. Fifth roots, 2, 32, fifth, 4 to the 5th, 4, 16, 5, 26, 5, 12, 243 for that one? Okay, 128. It's fifth. That's going to be 32 then, right? It's the only number that we're done. Six 250. What's that? 625. Okay, 5, 25, 125, 625. 3125, so 3125 times 2.
How did you get a...
Okay, we need to be able to change entire radicals to mixed radicals. That's what's known as simplifying. So this would be complicating, I guess. We will take this and express as an entire radical. When do we want to do that? Well, if we want to compare radicals, we know that the root of 126 is bigger than the root of 125. But maybe we don't know what's bigger between when they're expressed in radical form, right? Or as mixed radicals, right? Is 5 root 2 bigger than 2 root 5? You know, is 3 root 4 bigger than 4 root 3? I don't know necessarily, right? But if we convert them to entire radicals, then we can look at it and say, oh, but the root of 48 is bigger than the root of 44, right? So we can do it that way. So how do we do this? We put the 5 back underneath the radical sign. So since it's a square root that's going on, I square the 5. I write 5 as the root of 25. I then combine these, right? We're just working our way backwards. It's the root of 25 times 2, or root 50. Okay, again, if you just want to write the answer, if you want to look at negative 4 root 3. Now, I can't put the negative underneath, right? If I do that, I'll end up changing this thing to a positive. So if I write that as, oh, let's square the negative 4 and get root 16, then all of a sudden there's no more negative in there, right? Whereas this is negative. So it'll always be negative. Okay, 4 squared is 16. 16 times 3 is 48. So if your answer is negative root 48. Okay, but how do we get there? It's the negative of root 16 root 3, which is the negative of 16 times 3, which is negative root 48. Okay, 3 squared is 9, times 2 is 18. X, to put it under radical sign, is x squared. So it'll be 18 x cubed. Okay, again, if you want to go there in one step, great. If you want to take more, works as well. Take the 3x, put it underneath a square root sign. How do we do that? We square it. So 3x becomes 9x squared times root 2x. So it's 9 times 2 times x squared times x, which gives you the 18 and the x cubed. Next one is the root of 80x to the 6th. And if you can look at it and get that, perfect. If you're going to do that, just make sure you're doing it all the time, right? Not that you hit and miss. Oh, I get about half of them right that way, because then on the test you'll get about half of them right. Okay? So this is 16x to the 6th, right? And all I'm doing is squaring. Okay? So it's 16 times 5 times x to the 6th, and that gives you the 80x to the 6th. All right, so you do this next one, and then you can start working in on the next line. Right? Just remember on the next line, you're cubing things. If it's outside the radical, you're going to cube it. Okay, we got to cube the 6. 6 cubed is 216. Okay, now with the cube, I have a negative. I can pull that underneath the cube root, right? So it's the cube root of, I can cube negative 2 and get negative 8. So if it's an odd index, if it's an odd root, then I can take the negative underneath, right? Because the expression will still be negative. I'm just going to start skipping a little bit. Right? I mean, I think we see the method that has to go on here. It's only 27. Don't get too carried away. Uh, 135. Okay, I'll give you some time to do the last couple. Okay. Pause. Express in ascending order. So that's from what? Or maybe even the other way around. Ascending is going up. You ascend the stairs. You also descend them. Descending is going down. So ascending means from lowest to highest. Okay? So how do we compare these? Right? Well, this is pretty easy. 3 cube root 3 is smaller than 7 cube root 3, which is smaller than 8 cube root 3. So since they're like terms, then we just write them out. 3 cube root 3. 7 cube root 3. 8 cube root 3, right? Nothing exciting to do there. 4 root 6, 4 root 7, 4 root 5. What's smaller? What's the smallest of these? 4 root 5. What's in between? 4 root 6. 4 root 7. So those are easy to compare because they're all cube roots of 3, and then it's just multiples, right? You got 3 of them, 7 of them, or 8 of them. Well, that's pretty obvious what order. In the last one, they aren't all, but they're all multiples of 4. So root 5 is smaller than root 6, which is smaller than root 7. So 4 root 5, 4 root 6, 4 root 7. What do we do in the next one? They're not all 9s. It's 9 and a 5 and an 8, and they're not all the same radical, right? It's root 2, root 6, root 3. So like, are 8 root 3s more than 5 root 6s? Are 9 root 2s more than 8 root 3s? So what we're going to do is we're going to change these from mixed radicals to entire radicals. So this becomes, I'm not showing details anymore, right? It's just here's the answer, and you get to figure out the details yourself if you want to. 9 root 2 is equal to the square root of 162. 5 root 6 is equal to the square root of 150. And 8 root 3, right? If you have any question about why those are, you got to work it out yourself, right? I'm just doing big boy math now, which is I'm just going for answers, right? So that's the root of 192. So in order, 5 root 6 is the smallest. 9 root 2 is the middle, and 8 root 3 is the largest. Okay, and the next one, they're all cube roots, right? Because we can't really compare cube roots to square roots, right? I mean, if I put them together as entire radicals, comparing a cube root to a square root is no basis of comparison. If you got to do this, you can also just plug it into your calculator. Just go 9 root 2 and see what it's equal to, and 5 root 6 and see what it's equal to, and 8 root 3 and see what it's equal to, and then arrange it in order. Okay? So if it's multiple choice, knock yourself out, use your calculator, right? But depending on how it's phrased. Okay, 3 cube root 5 is equal to the cube root of 135. 2 cube root 15 is equal to the cube root of 80 and 40, 120. And 4 cube root 2 is equal to the cube root of 128. Okay, now I hope you know how I got those, right? I just had to cube the 3, which is 27, and 27 times 5 is 135. Cube the 2, which is 8, 8 times 15 is 120. Cube the 4, which is 64, and 2 times 64 is 128. So smallest is 2 cube root 15, followed by 4 cube root 2, followed by the largest, 3 cube root 5. But wait, there's more. Okay? So we got E. Now, this time we have cube roots and square roots and fourth roots. So how do we compare those? Huh? Well, yeah, just find the decimal equivalent, right? Just work them out. Okay? Because if I put this together and get the cube root of 686 and the fourth root of whatever, and the square root of 80, so what? I still can't directly compare them, right? I can't compare. See here, I can compare cube root of 135. I could compare 3 different cube roots or 3 different square roots, right? Because they're kind of obvious. Root 162 is bigger than root 150, but is root 680 is the cube root of 686 bigger or smaller than? So in this one, we only have one choice, right, which is to go for decimal equivalence. So what is 7 times the cube root of 2? How much? 1 more? 8.8? 8.8. Okay, what is 6 times the 4th root of 5? 8.97. Nice, these are close. And what's 4 root 5? 8.94. Okay, so what's the order? It's 7 cube root 2. It's 4 square root 5. And it's 6 4th root 5. And they're all pretty close to each other, right? Okay, they're not very far apart. But in this case, you can't compare apples to oranges, right? I can compare cube roots to each other. I can compare square roots to each other, 4th roots, but I can't compare a square root to a 4th root to a 5th root, right? Or to a cube root. Next. Oh, looks like we're done. All right, so then you have, well, what you're going to do now is you're going to review for tomorrow, right? Then tomorrow night, you can do the homework for this, which is 278, 1 to 7, etc. Right? And then on Wednesday, we will pick up with adding and subtracting radicals and so on. 1 sec, I just got to stop this.